Hi guys, this is Mr. Corzine. We're going to work on the 3.6 notes today, and I pretty much showed you all the tricks about solving proportions using cross products yesterday in class. But I just want to give you some extra support. You'll watch this video, and then you'll complete the homework with whatever time you have in class. If you don't get it done in class, then you'll do it at home. So here we have several different problems. We're going to start with I'm gonna do them with you. Follow along with me and fill out your notes. Okay. So we have a proportion right here. This is a proportion. It's when we have two ratios set up that are equal to each other. And when they're equal to each other and we have a missing spot right here, that's a proportion. You can solve that proportion for the missing number. So let's go ahead. I'll change colors and let's start. 32 times 7 is going to be down here. And that's going to be equal to 16 times x. Now, after I multiply 32 times 7, let's see, that's 210 plus 14. So 224 is equal to 16x. And what I'm doing right now is I'm getting out my calculator. You should also be getting yours out. I will divide by 16 on both sides. That'll cancel out, and that means that x is equal to 224 divided by 16. That's 14. Change colors and move on to our next one. Here we have x times 9 is going to be equal to 3 times x minus 4. This problem's a little bit different, a little bit more complicated, but we know how to solve it. This will be 9x is equal to 3 times x minus 4. After the last chapter, when we were able to deal with the distributive property and also variables on both sides, we should have a plan. We should have a clue on how to do this. Let's distribute first. 3x minus 12 on this side equals 9x. Then I will subtract 3x on both sides. So I get a negative 12 is equal to 6x. I think now we can see if you divide by 6 on both sides, you'll get x is equal to a negative 2. One more. Let's go with green here. 5, in order to solve this proportion, we'll do 5 times m minus 6 is equal to m times 4. So 5 times m minus 6 equals 4m. Not too bad. I'll distribute 5m minus 30 equals 4m. Change colors here real fast. I will subtract 5m. So I get a negative 30 is equal to a negative 1m. And then if I just divide by a negative 1 on both sides, I find out that m is equal to 30. Hopefully there's no questions on that. I think it's pretty straightforward. But if you need to go back and retry those again, go for it. It'll be good practice. All right. We want to now be able to set up our own proportions. And so we have to translate from this problem. It takes 30 tomatoes to make 8 ounces of enchilada sauce. How many tomatoes would it take to make 12 ounces of enchilada sauce? So set up and solve using a proportion. Well, proportion is made up of 2 ratios. So I'm going to have a ratio here, and that's going to be equal to another ratio. And what I want to make sure and do is make sure to label my numbers. When I label my numbers, that helps me to always get them in the right spot. So when I compare 30 tomatoes, or like kind of pair them together, 30 tomatoes with 8 ounces, it doesn't matter if I put tomatoes on top and ounces on the bottom. It doesn't matter at all. I could flip it and do 8 ounces on top and 30 tomatoes on the bottom. As long as I have this pair correct, I'm in good shape. Now I go to the other side. I will have, in this one, I will have tomatoes on top and I will have ounces on the bottom. And then I just need one number. it says, I need to make 12 ounces, but I don't know how many tomatoes. No problem. I can figure that out using my cross products. Again, I'll change color so you can see everything. Maybe I'll do green here. So 8 times something, we can call that 8 times x, should be equal to 30 times 12, which is 360. Well, now I'm going to divide by 8 on both sides. It's pretty simple. And 360 divided by 8, does anybody know? I got to pull up my calculator here. 360 divided by 8 gives me 45 tomatoes. Which now I think makes sense. 30 tomatoes for 8 ounces, and then 45 tomatoes for 12 ounces. Here, we've had in the past, I'm sure in 7th grade, you had scale factor problems where you're trying to change from from a model into real life. Maybe you've dealt with a map or something like that. There's a scale involved. Those scales always are set up by a ratio, and you follow that ratio in order to remain true and keep everything measured by the same amount. So here, a ship model kit has a scale of 1 feet to every 600 feet. A completed model of the Queen Elizabeth II is 1.6 feet long. Find the actual length by setting up and solving a proportion. So here, I want to set up my ratio 1 foot for 600 feet. But I'm going to put in an extra label. My extra label will be model on this side. Model is in parentheses on top, and my actual measurement is on the bottom. I don't have to keep doing this throughout, but when I set this up and I put my other ratio in there, I want to make sure that my model measurement is on top and my actual measurement is down at the bottom. Now they've given me, I'm going to be feet on top and bottom, but since those labels are the same, it can be confusing. That's why I have the extra labels here. The 1.6 foot long Queen Elizabeth model, that number goes here on top, 1.6. And then down below, the actual length, I don't know what it is, so I'll call that X. And now I do the math. 600 times 1.6 is going to be equal to 1 times X, which is basically just X. So I get my calculator out again. You should have yours ready to go. If you don't have it out yet, please get it out. 600 times 1.6 means X is going to be 960. In this case, it means the actual ship that they're making a model of was 960 feet in real life. All right, so this brings us to the like an additional section. So it's an extension of unit or section 3.6, and it deals with similar figures. Similar figures are figures that they're similar to each other. They're the same shape. They're just different versions of the same shape, and they have a connection that we can use proportions to help solve the missing lengths. Here I've got a triangle, and this side QS matches up with EG. Okay, there's a connection between these two. Okay, there's a connection. And so I'm going to write that as a ratio, 24 over X. And that will be equal to the same connection that is between other corresponding sides. Okay, so the corresponding sides here, the longer side, or the bigger triangle side is 10. And then for the smaller triangle, that corresponding or matching side is 5. So now I have a proportion set up, and I can go ahead and solve. 24 times 5 is going to be equal to 10 times X. 24 times 5 equals to 10 times x. I know that 24 times 5 is going to be 120 equals 10x. When I divide by 10, I find out that x equals 12. So that's going to be 12 meters. And I believe that makes sense. Basically, the measurements here in this smaller triangle are half of what the measurements are of the big triangle, and that fits. For number 7, this is a classic problem as it pertains to like proportions, ratios, similar figures. You've got the woman who is 5.5 feet tall, and she casts a shadow of, we don't know. And then the sun strikes the same angle and casts a 2.2 foot shadow of the lady. Oh, here it is. And a 6.4 shadow of the post. Oh, so the lady, I'm sorry, I'm not going to draw a picture of the lady this time. But she has a 2.2 foot shadow. The sun is, we'll call the sun, we'll make it red over here in the corner. It's casting a shadow. At the same time, we've got this post, and the post has a 6.4 foot shadow, but we don't know the height of it. Now, that's the same angle. The sun is making this same angle for both of them. So they create a similar triangle, a similar set of right triangles. So I will see if I can set up a proportion for that. I will take and use these corresponding sides, 5.5 and x. That's going to be equal to 2.2 and 6.4. After I do a little bit of math, I should be able to set up and get the right pen here, multiply across. So I'll go all the way over to the left-hand side over here. 5.5 times 6.4 is going to be equal to 2.2x. On my calculator, I have to make sure I multiply 5.5 times 6.4. I get 35.2 is equal to 2.2x. Then I'm going to divide by 2.2 on both sides. When I do that, that gives me x is equal to 16. So the missing length or the missing height of this pole is going to be 16 feet. That's a standard measurement for a light pole. All right, so now you guys will head in and on page 175, this is your similar figures. And down here below, this is solving using cross products. Work on those here in class. Whatever you don't get done is homework, and I will see you guys tomorrow.